recently purchased off of eBay for about $14 a 300 volt, 100 amp dual LED meter combo thingy, and they also came with 75 millivolt, 100 amp current shunts. You have to have one of these in order to operate it. Now, the panel itself is very small, and it runs off of anywhere from 4.5 volts to 30 volts, so it's very versatile. On the back you have two connectors. One is for power, and I'm running out of 15 volts right now. And the other connector is for the data input, and it has 3 wires. 2 of these wires get connected into a current shunt, yellow and black, and red just goes to the positive of the power supply. Black goes to the black of the power supply, like so. And now if you were to wanting to run a load off of this, you would run your load off of red and yellow. I currently have this power meter hooked up to run off of this 16 volt power supply and measure the voltage going from this power supply charging these lithium batteries. Now if I bring the voltage up, you should be able to see the amperage go up. I have to say I can't really get the amperage to work right though. For some reason it's wonky. And what's worrying is no matter how much I adjust the potentiometers in the back of that unit, I can't get any of them anywhere close to the right amperage reading. Okay, so I've taken this potentiometer and I've put it in between the shunt and the negative cable. Oops. And as you can see, I'm pulling 1.28 at 1.028 amps, so basically 1 amp. And now if I change the resistance, that changes the reading. It's a little sensitive. Okay, I think that's pretty much calibrated nicely. Now I will take this potentiometer out of the circuit and measure what the current resistance of it is, and I'll put a resistor in the circuit. But I'll put a resistor that has a little higher rating in it so that I can put the calibration potentiometer in the back of this little into the center. That way I can actually really use the calibration potentiometer in the back of that. So it's reading about 60 ohms. I'll go look through my collection of resistors for anything over 60 ohms and under 100 ohms. Thankfully, adding a 35 kilo ohm resistor in between the yellow wire and the current shunt does help quite a bit. Let's bring the voltage up. For my load this time I'm running a car headlamp. Let's get it to exactly 3 amps. And it's closer, it's 2.8, but oh well. Now what the main problem is the current shunt isn't cut right, because see, this black part is a somewhat resistive metal. Still, the entire thing only has a resistance of like a few milliohms, which is extremely small. And for them to adjust the resistance, they cut into it. That's where you see that little gash in it, because that makes it more and more. The further you cut into it, the more resistive it gets. So I may take one of these and cut a bit into it some more to get the resistance right. Okay, so here is the whole thing set up without any resistor on it, and now we're going to cut into the main beam thing. Well, evidently it needed to be less resistive instead of more resistive, so I made the problem worse. But now we know what happens whenever you cut through a current shunt. Maybe I'll try to weld that closed and see how that goes. Or actually, I think I got a better idea. How about I solder it closed? I think that worked out pretty good. Now let's test it out. Okie dokie, so it's soldered. I've soldered in the gap, and let's test it out. Bring it up to 12 volts and pull out 3 amps. It's not that bad actually. 3.2 amps it says, and it's only pulling 3 amps. I'm able to settle for that. I wouldn't mind being 0.2 of an amp off. So in the end, I gotta say I'm quite happy with how these turned out. And I'm probably glad that I got 4 of them too. I got 1 for my electric bike, and I got 2 for building 2 chargers, and I got another one for me to accidentally drop and break. And it worked out pretty good. Well, I hope you learned something from this video. Next time I should be working with this 10 to 60 volt DC step-up converter. And after that I hope to show this 300 watt industrial soldering iron from at least the 1960s, maybe even as far back as the 1940s. It's difficult to tell when it's made those because they still make this exact same model, except for the new ones don't have a cloth covered cord or a wooden handle. So it's a little difficult to tell when it's from. But either way, it should be loads of fun. Well, see ya.